Good morning. Hello. Can you hear my voice? Okay. Today, we will give you this kind of a brief introduction about Hong Kong CRC by the manager, Dr. Hao Liang. And so, of course, as I mentioned to you that we have this Hong Kong CRC is the research project, right? Research center funding. I work with Professor Zhang Li, and then we see $300 million. So that it's not small money; it's pretty big money. Can you write a proposal to get money from $100 million from Hong Kong government? It's something. It's not small money. So that at this moment we about more than 60 people, right? And full-time people work on this kind of automation and robot system for building construction. So that we do have provide this kind of some intern for some of you if you're interested. And I think the pay is reasonable. If you find a summer job in Hong Kong, now how much you can get? So that this is some special Hong Kong ITF STEM internship scheme. I don't know how much money you can make by work for some for summer kind of some intern summer job. How much money? I want to know. It is, I think it's not too bad. I was not too bad. And of course, you can learn, right? With also full-time, this kind of full-time postdoctor, MVRA work on the real construction, this kind of industry thing, right? And automation is not just something you work for McDonald's or some kind of this restaurant job doing that. So this you can learn something more practical, this kind of engineering. Okay, so that I just get you know this is something. Of course, they also have this kind of summer camp. Summer camp is different from the summer intern. Is they give you this kind of practical training about how you work as a team of students on practical design of real product, market research, design, how you work as a team, and how you form this kind of team to make a real product. So this is the two different kind of opportunity for this kind of a job, summer job you may consider. But unfortunately, for summer camp, because this is education program, so that you cannot get this kind of monthly this kind of salary, but you get this kind of very good training to how to work on at a smart company to make this kind of product design something. So it's a very different thing. Right? Of course, we do also have some additional Europe project with pay with salary. So that I tell you, if interesting, you should try to think about this kind of additional summer job. Okay, so that this is give you some additional this kind of job opportunity. Okay, and of course the second thing is I think I remind you we have second this kind of quiz will be available I think very soon from 12 a.m. about 1 day you can finish. You can see it can be for you to think about how to work on this kind do some exercise while prepare for this coming this kind of exam, so that I just remind you some that this I do think is important for you to study, right? Don't wait until the last minute. Okay, so that for the final exam, the same thing. We have 25 questions, MC question. It's not challenging. Okay, the same thing. Our quiz, the same. I just give you some exercise. Well, again, this is not the something you have spent long time to study, but it's important. You need to really study, not just listen. Okay, so that it's not very difficult, I would say, but still, I can see still some students can get very excellent result, and some students still don't spend enough time. Okay, so that again, do you any question about this? Similar, I think. Yeah, I think for the final exam, similar to the meeting exam, you just try to see why, because it's MC question, so that it's not something you have to do a long time calculation, so it's not difficult. Okay. Again, so I just give you this kind of thing. So okay, so if you have no questions, then actually the Hong Kong CRC manager is busy, has some meeting with a company, so that actually I just played this kind of the video this manager gave yesterday. So of course, if you have some question, again, you're free to contact by to send an email. So anyway, so here I just tell you about this kind of thing, so that again, so that is something useful for all of you to understand this job opportunity. One student asked if the content taught by TA will be tested. I think I will give you some basic concept, but not very complicated. I know the TA gave us some much more complicated thing. I will not test you very complicated this kind of thing. And I know that my student, peer student, TA, they give you some slide has some complicated equation. I will not test you very complicated thing. Okay, so that at least that you understand about those kind of concept while doing that. Of course, I actually invite actually I contact the vice president of Rocket, one of a big AR glass company in China, will give some guest lecture, maybe sometime, maybe this week or next week. So that I told you that VR AR would be huge market, right? All the company, why this kind of Facebook change name, Meta, VR AR MR metaverse will be, how big is the market? I don't know why Facebook, Google, they put a lot of money, they do this kind of VR AR metaverse. How big is this market size? Any idea? It is several international market research this kind of agency predict by 2030 you will reach about $1.5 trillion business. AR, VR, MR, metaverse, $1.5 trillion business. I can tell you something. It's quite 1.5 trillion. Can you believe? VR, AR, VR, AR, all these kind of members will reach 1.5 billion US dollar business. By 2030. Can you guess? Is this possible or not? What do you think? Anyway, I do think it's interesting for you to understand something. That's why let me show you some interesting thing I already put on, add additional thing on this thing. So it's at least many big company put huge amount of money, right, for this kind of thing. Qualcomm provide $100 million funding for you to apply, and then so that the VR AR will reach about some market research at 1.5 trillion, some 1.4 trillion anyway, pound anyway. So it's a big business. It's not small, right? So that's why this company, start company in Hong Kong, right, receive huge money, right, for his VR business, for video game. It's not small. Okay, I can see it's really a big business. So that so it's something I just let you know. It's interesting for all of you to think about. Of course, for this course, I also mentioned why in previous lecture, those kind of VR AR can be used for building construction, right? So that is something is important for all of you to think about. If this can be interesting for you to go in the near future, right? And though if you think about $1 trillion business, if you can get a share of 1%, how big is money? How big is market? If you really work on something related here, then 1% of $1 trillion is how big this market size. It's not small. It's a really big business. So anyway, so that I just tell you something important for all of you to consider, right, in the near future. Let me let this kind of our Hong Kong CRC manager to give a briefing about this Hong Kong CRC. Again, all this kind of project done by Hong Kong CRC is very practical to make a real product for real demand from the industry, building industry. It's something not for basic research, right? And some of this team, they really are going in a stage to register a company and will receive some VC funding. So that it's a real this kind of this kind of operation, okay, team application. So I just let you know this is something. It's not just for fun. It's not for basic research. It's really make money. All this kind of project inside Hong Kong CRC, it's not for fun. It's really make money. It's something, of course. That's why if interesting, you're welcome to participate this kind of do thing in Hong Kong CRC, while Hong Kong CRC intern, other thing. Okay, let me try to let this Halbert thing to. Oh, by the way, last night we have a video conference with UC Berkeley. Actually, this Hong Kong CRC is a joint research center with UC Berkeley, so that finally we will start this kind of collaboration. Hong Kong CRC with our UC Berkeley professor. There's a series of professor from UC Berkeley in ME and ECS AI with all the robotic sensors. So that yeah, as I tell you, finally last night midnight we have a video conference with UC Berkeley professor in EECS and ME, and so that finally we most likely we're going to have the real collaboration between Hong Kong USD, this kind of with UC Berkeley. Okay. Anyway, I just tell you, this kind of thing is an opportunity for all of you to consider. Okay. Okay. Sure. And today I will briefly introduce the center, and we have some inter program and also summer camp for the students who are interested to apply. First, let me have a brief introduction of the center, and the background is that the founding member of this center is Professor Zhe Xiang Li, the professor of ECE department. He is also the founder of DJI. You all may know the company doing the drones from UST, and he founded a base in Songshan Lake in Guangdong province. We call it Expo Park. This incubation center actually now have more than 60 companies incubated from the park,
and the surviving rate is more than 80%. Currently, within these companies, there are maybe 15% other unicorn companies, which means that the valuation is more than 10 billion. 1 billion. And all of them are the hardcore companies. We mean that all the companies are doing robotics. The main company, the valuation of those companies has exceeding maybe 80 billion. I have listed some companies in the mainland. You may heard about that the EcoFlow. This company is doing electronics, a battery, and he is also from Hong Kong. Some companies called Navo doing cleaning, CD doing the automotive company, and the High Robotics doing logistic robotics. Some IoT or some other different kind of robotic companies from Expo Park, the incubation center. So Professor Lee currently doing hardcore company incubation in mainland, and this is a very brief background. And you may want to know that why we're doing construction. The background is that you all know the vehicle production from maybe a century ago. We're doing it very, using handicraft to assemble all the components. But currently, all the vehicle production are automated. However, in construction industry, with maybe 100 years development, all the things are almost the same. So we have a question that if we compare the construction with the automotive, you may know that in the mainland, the construction occupies 22% of GDP, which is with the biggest industry in mainland China. However, the second one is automotive. Thus, we compare the development of these two industries. From the prehistory, we say before 17th, all the process are almost the same. We use some materials, wood and handicraft to make the vehicle and the building. But with the industry 1.0, with the invention of a steaming machine, automotive go a big step forward. However, in the construction field, it's the same as before. And with the invention of the electricity and internal combustion engine and the rubber, Ford, the car company Ford, has a production line, and then the automotive production go another big step forward. However, in the construction field, with invention of the crane and some cement, some new materials, it also go forward to build, as an example, in pair building. In the industry 3.0, Toyota has a lean production assembly, and in this period, we have light materials and electricity computers. Most of the production line are automated. However, in the construction, it's the same as before. And you all know that currently we have the unmanned vehicle, and we have auto driving, we have a car network. Tesla also has its mega factory. However, in the construction, I don't know whether you have the background of the construction. We all mentioned the conception of BIM, building information modeling, and the factory components. We all curious that how the construction can be developed with the high tech. Thus, we have studied some construction robotics in Japan, and you know, in the 1980s, they have researched some different construction robots by Professor Thomas Book. However, there are more than 200 prototypes produced, but currently, most of the companies still allocate more than 0.5% revenue to the R&D department. However, most prototypes just stayed in the laboratory stage. So no construction robots have ever been widely used in Japan. As an example, the Shimizu, one of the biggest Japan construction company, they have doing a spray robot in 1980s, and they have some iterations from first iterations to the third one. However, there are only 6 units produced. Thus, all the prototypes are terminated because the market is very small. There are also some other examples in construction robotics. For example, Boston Dynamics doing inspection. They use robotics dog to stroll around in the construction site to doing the inspection to measure the quality of the construction building. And there are also measurement robotics to measure the size of the wall of the building. And as an example, in US, doing the painting robotics, there is a company in Sweden doing dismantling robotics, and Okebo in Israel doing plastering. And you know, in US, there is a company called Dusty doing the layout to lay out the lining in the construction building. And we also have some other examples such as paving and the drilling company. And in our center in Hong Kong CRC, we now have 8 teams doing the construction robotics, same as the company listed here. We have robotics doing movement to move the construction components, for example, the prefabricated wall in the construction site. And we also have painting robots doing the painting for bridge, for the road. And we also have the measurement robotics to doing the measurement in construction site. So there are different kinds of robotics in our center to help construction companies to to improve their efficiency, to help their workers to do the job, something like that. So a brief introduction of our center, and you may know the Hong Kong government built more than 20 centers we call Inno Hong Kong Center to do the technology transfer. And our center is funded by UST, UC Berkeley, and the Tsinghua Berkeley Shenzhen Institute. We have the funding from Hong Kong government for 5 years with 300 million Hong Kong dollars. And the basic principle of our center is that we first bring in the industry companies, because most of the people from CRC are doing robotics, are doing mechanical, are doing computer science, doing ECE. So we actually don't know the pain points of the industry. We don't know the pain points of the construction. We don't know the problems of them. So we first bring in the industry to give us the critical needs of their daily life. And then we form a team. For example, we have the team from UST students. We have the team from outside, from the people with working experience, to form a team to do the multidisciplinary projects, to give the solutions from different aspects to the critical needs. So finally, we form solutions to prototypes to test whether the whether the product can solve the critical needs from the industry. And finally, we can doing startups to make the transformative changes for the construction industry. Thus, actually, we are not the traditional research center as those in the universities. We are the pre-incubation center to integrate different technologies to help the construction industry. And the professors in UST, in UC Berkeley, in other different universities plays the role of the mentors rather than the traditional PI who are leading the project. So the people leading the projects are the students, our employees from the center. So we have different professors from robotics, from construction, from sensing. These are the list to mentor you to do the project. And we have different industry partners. For example, those big companies in Hong Kong, Henderson, Shen Hongkai, Garmin, China State Construction, something like that. So we have the partners from the developers, from the contractors, from the equipments and the technology, different kind of partners. So the project process in our center is that the industry partner, first give us the directions and they give us the needs. For example, they need painting robots in their site, but they don't know how to do that. So we recruit researchers, we recruit students to first have 3 months to do the market research and to study the feasibility, whether we can integrate these kind of technologies to solve the problems. And within these 3 months, we generate a business proposal, for example, doing a pitch to the panels, and we have a review. We have a review of the proposal to evaluate whether this direction is right or we have to kill it. So we call it launch or die. And in the next step, we will build up the team. We will build up the team and to do the system specification, to deploy the key modules, to prove the concept of the first stage. So this stage, we have maybe a simple prototype to test in the real site to validate the concept. And if this stage is okay, we may go to the next stage, phase B, which lasts for a year to do the iteration, to do engineering verification test, to do this design verification test. So the process is that the topic or the project is not from professors, it's from the real problem, and you may need some time to know about the real environment, to know the problem. So the center give you all the support from mentoring, engineering, project management, IP, supply chains, something like that. So within these 2 years, you may have the chance to build up your own company in Hong Kong or maybe in Shenzhen or in US. So you solve the real problems by your team, and all the professors, all the center staffs are the mentors to supporting you, not driving you. You are the drivers. So the projects in our center, as I mentioned before, is towards the whole construction life cycle. So we integrate different technologies, for example, drones, robotics platform, and IoT, AI, different kinds of technologies to solve the problems for the whole construction life cycle, from the maybe first excavation and the building, and then handing over and maintenance something like that. So we have project to do that. This is the environment of our center. We located at a science park, and you know that it's very new, and we have a large space for you to discuss, for you to do prototyping and something like that. So, and we also have a sports space to play in ping pong, and a meeting room, something like that. This is a basic, very brief introduction of our center, and we have some events. One important event is to do the summer camp. The main process of the summer camp is that we have a different stage of the summer camp. I'll show beneath the page. First is that we will tell you how to define the problems, because you cannot learn that within campus as a traditional course. So we just bring you out to know how to define the problems. For example, we tell you, okay, there may some problems in construction companies, but how you define that kind of problems. And then next stage, we will teach you how to do engineering design. So the last stage is doing prototyping. So this is the whole process of the summer camp, and we have some steps. For example, you have to converge and then diverge, and doing brainstorming, doing prototyping. So maybe the capacity for the summer camp is 30 students, and we will divide the students for within maybe 5 to 6 groups. Each group we have 3 to 5 people with different background. For example, with design background, with mechanical background, with computer science background, with maybe civil background. So this is the process. And for example, we held the summer camp last summer. Week 1, we will get the industry insight. For example, we can collect the information from the industry. We will do the field trip research. And week 2, we will teach you how to do user research, how to define the problem, and how to form the team. And in week 3, we will tell you the methodology of brainstorming and how to seek opportunities and doing the iteration. And in the last three weeks, week 4, 5, 6, we will tell you how to do industrial design, UI, UX, and how to integrate supply chains, how to build your business model, how to do the prototyping. So actually, we use 6 weeks to decide a process of building a company, and you can experience the whole process of doing product, doing startups. So this cannot be learned within campus, either by the engineering school or the business school. You know, maybe you may learn the information from a business school, but you cannot do the real prototyping. And within this summer camp, we can do all the experience. So this is a very brief introduction. And if you want to intern in our center, just send your CV to the email career HKUST with the name plus summer intern. The intern is that you may do some integration, you may do some mechanical design, you may do some control for the projects, currently project. And if you want to generate a new project, you can apply summer camp. Send your CV to another email, admission CRC. So there are 2 different things. Doing intern, you may do some job for the current work. If you want to experience the whole process of building up company, the whole process of defining a new problem, doing new projects, you can apply the summer camp. Yeah, this is a very brief introduction for our center. Thank you, student, and thank you, Professor Lee.
Okay. Thank you very much. So I want to know if there's some deadline for the student to apply for both intern and summer camp?
Oh, there's no deadline for the inter application. So
Oh,
you
I
can,
see.
so students can apply inter within summer and also maybe winter for the. So we open inter application all the time, but there might be some time limitation. Then you can do the full-time inter in summer period, but in the fall semester, students can only do part-time intern. Yeah.
How about in terms of monthly, this kind of pay, a salary for intern? I don't know if that's a standard payment from the Hong Kong CRC or there's some. I don't know if.
Yeah. We have a scheme called STEAM, also from a Hong Kong government ITC, and the students can apply the summer full-time intern with a monthly pay 10,000 and 10,500.
Oh, okay, pretty good.
Yeah.
I say
Yes.
it's
This is
for each student. I think it's
this
pretty
is
good.
this is the standard rate
Okay.
for people who apply the STEM intern.
I see.
Yeah, regularly if
I'm sorry. There's some internet problem. Hello. Can you? Sorry, I got some. Okay. Anyway, I just try to. I don't know. Do you have any question about this introduction of Hong Kong CRC? Or you're interested to make money through working with the team in this Hong Kong CRC? Any question about Hong Kong job opportunity? Any of you want to work for Hong Kong CRC as summer intern? Anyone? No, for want to join the Hong Kong CRC as some intern? No one? No one should. I still want to know if you work for those kind of summer job, right? In typical Hong Kong, what's the typical payment? So in terms of monthly pay. Again, one student say it's still challenging, but I tell you, you are not. You are the student or intern. You say we already have full-time RA, postdoctor, MPhil student work on full-time basis. You just help those kind of full-time this team to work on something like relatively easy, right? Job as a UG student. Again, you are not at the leader. Okay. Again, you are not the key this kind of team leader. For doing that, but instead you try to your job is to help those kind of full-time, this kind of RA and postdoctor. Why doing that? You are not trying to work a complete new this kind of thing. Okay, so that's something you can say. Once you say is any grade requirement, I don't know. I don't know if it depends on the number of students who apply. Do you understand? If you're maybe 10, 20, 30, and then it's those kind of this kind of request from this kind of thing, right? On CLC, so it really depends. I don't know exactly the thing, but it depends on how many students will apply. So students say at this point I don't know exactly, but of course they do hope that you do have some reasonable this kind of basic skill, right? Basic things, so that the students say, yeah. Any other question for this summer intern or summer camp? No question. Oh, it's not interesting for you. Huh? Of course, beyond this thing, I told you there's also a series of Europe project you can get paid by doing this kind of more research-oriented things. So that as I told you, I do have the additional funding from the government for this kind of COVID-19 project, plus money, PCR chip, do the rapid detection of COVID-19, and then still it's a big problem, global problem. So that I do have a group of postdoctoral PhD work on things. So that anyway, so that if interesting, please try to email. I do think, right? As I show you, you try to send email to our this two email, I think. And let me see. I just remind you so that if interesting these things, please feel free to send email to this two email. One is summer intern, career, Hong Kong CRC. Another one here for summer camp. If you're interested, this one again, you have no payment, monthly pay, but you will get this kind of training as a show by this kind of manager. You will get the training to work as a team, how to work on the stock company and how to work on product market research things. So that these are two different kind of summer activity. Okay, so that I should tell you. Okay. Any other question or thing for this thing? Okay, anyway, so I just told again that this is almost the end of semester. I do hope that you can learn something interesting and useful. And of course, as I mentioned, I successful to get in touch with this kind of vice president of a rocket company who are making very good this kind of rocket AR glass. So that I do think this is quite cool. This kind of AR and can be useful for a lot more engineering and gaming. So that I think we will have additional this kind of online lecture now for all of you to understand this kind of quite interesting technology, AR glass and their system. So that I do think it's again, it's not me, right? So all the big technology companies in the world put huge amount of money in this area. There's must a reason, right? They say by 2030, that reach this AVR, reach $1 trillion business. So definitely it's not small. It's not small business. So I do think it's interesting and important for you to consider to understand about this kind of opportunity, right? Via AR, MR for all kind of engineering, right? So that's something I do think. Anyway, I get in touch with the vice president of these rocket, so that if again, I will announce on our campus site for use. Again, I know that this particular AR glass is competitive compared with Microsoft HoloLens 2, for sure. For HoloLens 2 is the one HoloLens 2 is about close to 30,000 Hong Kong dollar, right? For this AR glass, it's about 3,000 to 4,000 Hong Kong dollar. In terms of this kind of price performance ratio, definitely this is a good quite competitive. Okay, so that's why you look at this kind of online crowdsourcing platform like Indiegogo, right? So that this company received almost 8 million Hong Kong dollar internationally for these product. It's quite interesting. Anyway. No, I not ask you to play the game. I'm asking you how to use this one for a real engineering application. Okay, of course, video gaming is one part of the business for VR AR. Yeah.
Answer the call. Hi Phil, how are you doing?
Hey Maria, hi. I just want to check something.
So do you say so to be able to make this kind of very compact wearable AR glass, they require very sophisticated engineering, right? To integrate so many sensor and also kind of optics and also this kind of display, right? And also advanced this kind of semiconductor processor is not easy. It's not easy. I told you it's not easy. So that they have this company received the huge amount of the money from the VC to make this product. So that's why it's quite competitive as a product point of view. Right? I told you, compared with Microsoft HoloLens, this product is quite impressive. They really held a series of company in mainland China how to do this kind of smart manufacturing. Do you understand? From my point, it's quite amazing product in terms of price performance ratio. There's no doubt at all. I can see it's a quite amazing thing. Okay, so anyway, if that's why if you look at this kind of online cloud sourcing, so that they really receive wow $8 million money. You see, almost $9 million, $100 for this one. My PhD student already bought one, so that the interesting maybe in the following maybe I will most likely will receive this kind of AR glass from this company this week or next week, so that if interesting, I don't mind, you can try to borrow this kind of thing to give a trial. But anyway, I think the most important from my point of view is for how this can be used for engineering. For engineering, design, and also smart manufacturing, right? Especially COVID-19, we're big trouble. So that how can we use this kind of advanced technology overcome all COVID-19 for this kind of smart manufacturing? That is something I do think is important. Anyway, I already invite this kind of Rocket vice president to find some time to give this kind of 1 hour online, this kind of a seminar about how this rocket is, again, it's not for gaming. It's for real engineering application, right? How to work on design, how to work on smart manufacturing. I personally, I do think this kind of technology becomes so important for COVID-19. Yeah, and so that I do recommend you try to understand more, right? How it can be used for practical, especially for our engineering, design, and manufacturing. Okay. Okay, so I think we have to go to our lecture, so that let me go back to our lecture, so that we already start this kind of water supply, and so that again, so we will not just talk about repeat, but again, the key thing here is water is important for everybody, right? Unfortunately, in the coming 1 or 2 years, we may suffer this kind of shortage of water globally because the global weather, right? Global warming or something. We have a rapid this kind of violent this kind of thermal cycling, right? The temperature in different part of world getting more rapid heating cooling, right? Doing that. So we have a big fluctuation of temperature, right? So in the case we have heat transfer, very violent heat transfer, convection, and then things. So got a lot more this kind of typhoon, hurricane, and also storm, right? And also we sometimes we have no water. So it's a very, unfortunately, we are going to face a very big challenging in the coming this kind of year. So that I just let you know that it's water become a very big problem, and then so that of course beyond this kind of storm, right? Big rain, we also have hail. So this is another problem for many places in the world. I didn't say. I just tell you no. And again, we already mentioned about this thing. While in particular, I told you, although we have so much water, right, on the earth, but we only have a very small percentage of fresh water we can use, right? This is a big problem, right? So that of course we have human cause a lot of pollution, so that we really get our fresh water we can use. In reality, it will be even smaller. So that in near future, so that create a big challenging for many people in the world. So that it's important for all you to understand this kind of a big problem, global problem, I think. Yeah. And okay, I think we also mentioned about this kind of a problem of this kind of storm water, right? And it cause pollution. In our previous chapter, we mentioned this one, right? And then so this can cause some big problem for this kind of pollution, right? Pollution, and then so all this thing is, unfortunately, we do have this kind of a series of issue, right? A second thing is, of course, we have additional water supply, not from surface water, but also from this kind of groundwater, right? Underground water. But the same thing, we have we have so many this kind of manufacturing plant, farming, and so that cause a lot of pollution, right? So that this pollution also cause some big issues. So we probably cannot use all this kind of groundwater for our supply, right? Or we cannot maybe need additional this kind of purification of this water, right? So this is something, unfortunately, right? And then of course another things we also mentioned about this the concept of eutrophication. So that again, because we are using a lot this kind of provide this kind of when we do farming, right? And then we provide this kind of fertilizer, right? Do the farming, and then sometimes too much, and then in order to increase productivity of this agriculture, right? This kind of farming, and then too much this kind of nutrient will not use up in our this kind of agriculture industry, and this kind of chemical will pollute the water, right? In the river, or maybe seawater, ocean, right? And lake. And in this case, you will trigger a lot this kind of spatial process, right? And then a lot this kind of they call the plankton. Plankton is very small, tiny, this kind of microorganism that will continue try to take this kind of nutrient, right? And in this case, too much this kind of plankton, right? Plankton, and then in this case become use a lot of kind of oxygen, and then so those kind of fish and other things may die because lack of this kind of oxygen. So this is a very big problem. Actually, also in Hong Kong. So that I have an ongoing project with our former Vice President of UST, Professor Joseph Lee's group, right? So we have a special funding from Hong Kong government. How can we try to do the real-time monitoring about this kind of problem? Okay, so that typically in Hong Kong we have about 20 this kind of species of this kind of algae or plankton. so that which can create big people about 20 types of this kind of algae or some spatial plankton. Okay, so this is something can create some big trouble. No, in this kind of ocean. Okay, seawater, and which can really create a big trouble, big trouble. Okay, so this is something, and then the problem is how can we solve the problem? Hong Kong government do have people to monitoring of this kind of pollution, but unfortunately, typical way is collect the seawater, right? Maybe some selected site, right, near the Hong Kong, this kind of ocean, and then try to go to the lab, right? Hong Kong government lab to do, oh, do we have this kind of big problem? A lot more, this kind of dangerous, this kind of algae or plankton, right? And then can cause this kind of algal bloom, harmful algal bloom. So this is a typical problem, right? So that the problem is they call it harmful algal bloom, right? The HAB. So this is actually the government of Hong Kong do have a group of people try to do marketing, and then how can we make this kind of actually I do have project to think about how to make a smartphone microscopy, right? And then we take a picture with additional take a smartphone microscope, right? Take a picture now near this kind of seawater near Hong Kong, this region seawater, and then so that we use additional maybe AI machine learning to identify those dangerous 20 types, and then to see can we do this kind of real-time monitoring about pollution, water pollution, right? And then this is something, again, I have an ongoing project. If you're interested, you're welcome to join my group, my PG group, PhD student and postdoctor on this kind of water pollution project with our Professor Joseph Lee group. So that I tell you, this is I just show you the very simple slide, but in reality, it's still a real problem. Okay, it's not a small problem. Okay, even in Hong Kong. And then of course, we also mentioned the key thing here is now we have caused some human caused some pollution, right? And pollution will deplete now this O2, and then many seafood, why the fish will die. So that something is important for everybody to think about. Yeah. So that just show you this is something important thing. And of course, one additional thing is how the question is how can we cause some this kind of have some kind of water conservation, and then how can we minimize this kind of pollution, right? So that it's important. Unfortunately, we have a rapid increase of this kind of population in all the big cities, right? And also a lot more industry, right? And so all this creates some big trouble, right? Creates some water pollution. And again, so that I just tell you, this is something is important for all of you to think about this thing. And then, so that again, so one important thing here is for water supply, we have to have more quantitative way to understand what kind of water we can use, right? From those very dirty water, right, to drinkable water. So this is something important for all of you to think about in terms of this kind of water quality. Of course, in terms of Hong Kong government or many government, they do have some maybe standard for this kind of quality control of this kind of fresh water. Why? So this become quite important thing. Quality control means we need to look at all this kind of chemical, right? Concentration and a biological concentration of some maybe bacterial or other things. So this and these are all important things, right? Typically, we will see those kind of turbidity, right? If the water become it's not clear, right? If many this kind of maybe some pollution, your water become not transparent, right? So that and then alkalinity is also quite important thing. And then of course additional those chemical or something, right? If you have some additional maybe some metal ion, in different kind of metal ion, right? Metal iron, copper, so that we have a lot more pollution, right? From maybe from building and from manufacturing plant, and cause some pollution of this kind of water. So this is something, unfortunately, we have a series of this kind of issue, right? For this water pollution and different pollution, and then we have different color. I can see, okay, so that you see, if you have some pollution, storm water, then your water may be yellow brown, right? And some algae, red, right? And then some special phytoplankton algae, green, and mixture of things. So there's something, even looking the color, we can have some idea about this kind of pollution issue. And salinity is another quite important issue, so that if some of this kind of water supply, they have certain kind of chemical or ion, right? And then this can change salinity, right? And then this may be cause some problem, right? Maybe it's too much, and then we cannot drink. We had to have to do additional water treatment. And again, so there's an additional issue about water quality is if you have too much this kind of spatial ion or mineral content, and then they have another issue about hardness of water, right? So that it's not related to this kind of sound mechanics, like Young's module thing is related to those kind of additional concentration of those kind of some mineral content, Ca, magnesium, right? So this is something can be important issue in some city, some part of the world, okay? And one more is conductivity, right? If too much ion in the water, then conductivity may cause some big issue, right? So that of course typically I think they have some special, maybe the meter to measure conductivity of this kind of water, right? So that typically we use this kind of pure water for in the clean room for microfabrication of this semiconductor chip, our micro machine chip or something. So that that's typical thing, right? So that, but of course, typically in those kind of water supply, right, from maybe Hong Kong government, so that they still have certain ion, but it should be reasonable, right? And typically, I show you that we have a range of different kind of conductivity, right, for different water archer pool water, typically using in industry, especially for our like clean room facility. Hong Kong USD do have a very good the clean facility, so we provide this kind of 18 mega ohm, 18 mega ohm, this kind of pure water, or DI water, deionized water, while for semiconductor or micro machine manufacturing process for the chip. But of course, typically we're not using, I see, for steady supply, typically is in this range. Seawater has a much more ion, so it's a much lower this kind of thing in terms of resistivity. And then of course, pH is another important thing. If you have certain kind of hydrogen ion, then in this case, we may cause some big trouble, right? So that is another thing. So that among that, actually, is one more is oxygen concentration, especially in water supply. Well, typically they look at the important the BOD, biological oxygen demand, which relate to how this relate to this kind of supply for oxygen in the water for some this kind of human, animal or thing, right? So that this is something in terms of quality control. So typically, there's certain kind of criteria, right? So that to make sure that we have certain kind of a sensor to measure this oxygen concentration in the water. Do you understand? So typically, this is something I think quite important. Yeah, and then of course we also need have additional maybe sensor to measure this kind of spatial concentration of some chemical, nitrate, phosphate, and other things. Anyway, so that I think we almost reached the end. Anyway, so that I just tell you about this thing. So that and then of course now we talk about another quite important thing for water supply, especially for Hong Kong. In general, Hong Kong doesn't have enough fresh water. We had to buy water from management, especially from Guangdong province, right? So that every year, Hong Kong have to buy this water from Guangdong province, Donggang, this thing. So that's something, and then we build. Typically, of course, we buy water from Guangdong province, right? And we also have certain kind of special this kind of way, right, to make sure that we can deliver this water from this kind of Guangdong province to Hong Kong, right? So that there's certain kind of this kind of water supply channel, right? So that you see from this typical route to let this kind of fresh water from Guangdong to Hong Kong. Okay, so that here you can see this typical summary of the from this Dongjiang, this kind of river. So there's certain kind of a way to deliver, right, the pump this water now to Hong Kong. So there's a certain you need to have a series of pumping station to make sure that this water can go to Hong Kong. Do you understand? So this is the cost, right? So actually, we need to buy this water every year. It's not small money. It's quite big money to sing. Yeah, and so of course in Hong Kong we have additional reservoir, right? And here you can see typically we have about 10 reservoir to store those kind of fresh water. Okay, so that typically near our Hong Kong UST. Which one is close to Hong Kong UST? Huh? What do you think? We do have, right, a series of these kind of reservoir for different part of Hong Kong, this kind of people to use, right? So this is something I think quite important for all of you understand. And then, okay, again, so here this is a basic summary about all this water quality we mentioned in previous slide. Okay, and then of course when we look at the real this kind of water supply system in general, so that let's do a series of more sophisticated this kind of water supply piping and pump this kind of water from Guangdong province to Hong Kong. Okay, so this is a series of engineering, right, in terms of to make sure that we can really get this kind of good and fresh water. Okay, and in general, Hong Kong do continue to consume more water, but of course we don't have a lot of this kind of water manufacturing industry, so that gradually I think the demand of water supply now is saturated, I see. Okay, so that that's something is it depends on how you look at it. Typically, if you have a lot more this kind of industry, then most likely you will consume a lot more water. Right? For example, as mentioned, like the TSMC in Taiwan, wow, they continue to build a lot more semiconductor manufacturing foundry to make the IC or main chip. So in this case, they consume a lot more water. Okay, it's because you know when we do this kind of microfabrication of semiconductor chip or this kind of microsensor chip, so that every time we need to do this kind of fabrication process we mentioned in previous chapter, and then to clean it, right? And then in this case, Hong Kong used to have in 1980, we used to have a 6-inch clean room, semiconductor clean room fab, I think in this region. But unfortunately, most of this kind of factory, semiconductor factory, 6-inch fab was phased out. So that that's why we don't use a lot of this kind of water for industry. Okay, and again, so that of course Hong Kong have now reached about more than 7 million people, and then so that I can see it's in general it's visible. I think we're not consume this kind of too much water, right? The increase of this kind of water supply and demand it's not a big problem. Okay, and then of course in general as I show you here, so that we have a gradually increase, right? In the past 20-30 years, population of Hong Kong could increase, and then our consumption of water is increased, but not increased to like crazy. So that's okay. Yeah. But of course, in the near future, if we have continued to have a more population, so that and then what do you think? Do we have to get more fresh water, or can we think about another thing? Can we build this kind of new kind of plan to turn seawater into the fresh water, similar to this kind of Singapore? That's another important. Can Hong Kong build this kind of desalination plan to turn this kind of seawater into fresh water, similar to this kind of Singapore? What do you think? Do you say every year Hong Kong buy a lot of this kind of fresh water from Guangdong province? Can we build? Okay, one student mentioned maybe near the TKO, Jungle O. I don't think it's reasonable if we can build this kind of plan to turn seawater into the fresh water. I think would be more robust, you say, especially in the following years, 1, 2, or 3 years. Globally, there's some clear prediction we have shortage of fresh water, so that I do think it's important to have additional way to generate seawater, right? For Hong Kong, that's something it's important. yeah, okay. And again, in general, Hong Kong here, of course, over you understand, every family or even our Hong Kong USD, every school or something manufacturing company need to buy this kind of water from this kind of Hong Kong government, right? This kind of thing, so that so this is thing typically. So you will see that they're different, right? In terms of this kind of a cost, I think it's different, right? So of course, I can see most likely Hong Kong government prefer you have to use minimum this kind of water, right? So from supply, so that that's why the different kind of water tariff, right? So that if you use small amount of water, maybe you'll be you can see first tier of 12 meter cube is free of charge. If you use second tier, then you charge 4.16 Hong Kong dollar and each more. They gradually try to increase the cost from zero, right, to more and then more. Okay, so this is something I think most likely Hong Kong government want everybody to be carefully use this kind of fresh water, right? So that's something important for all of you to make sure you can carefully to conserve this kind of water conservation is important. Okay, and of course in Hong Kong we don't have enough fresh water. That's why Hong Kong do use seawater for flushing of toilet. So this is something I think quite unique, especially I think all of you are too young. Right? In 1950 and 60, Hong Kong people do suffer the shortage of fresh water. If you ask your parent, grandmother, maybe they know. Why in the 1950, 60, they do have a period of time, Hong Kong don't have enough this kind of fresh water. I don't know, do you have any idea? In early day, maybe all of you are too young, so that Hong Kong do have certain period of time have water shortage. So this is in 1960. So that time, so that the people have to maybe carry the kind of a bucket to this thing. So it's something I do think all of you are too young. You didn't experience this kind of shortage of water supply. So this is something important for all of you to understand. So that in old days in Hong Kong, they do have certain suffering. We're suffering the kind of the water supply in old days. So that it's not something all of you are too young. So you didn't have this kind of experience. But if you ask your mother, your grandparent, probably they do experience this thing. You see, water supply, 1960. So that so this is something the real suffering. No, not you, but the old generation. Maybe your parent and grandfather, grandmother, they do experience about this kind of big trouble. Okay, in old days. Okay, that's why I do think it's all of you need to think about how we, for engineer, right, we need to think about this kind of practical engineering. How make sure that we can have enough this kind of fresh water supply, right? So that's why Hong Kong government built additional this kind of infrastructure to use seawater for flushing. In this case, we can minimize the kind of fresh water demand. Okay, so that this is something important for all of you to understand. Okay, anyway, so that I think of course for water quality of seawater, so that is if you want to use this kind of seawater for flushing the toilet, still that's why it still need have certain kind of quality control, right? So that typically this is typical requirement, right? Make sure the quality control of water is still important for even for seawater. And then typical here to show you about how we can use seawater supply system, why? So that they do have a certain kind of a pumping, why? Pumping system, right, to get those kind of seawater, and then gradually I do additional reservoir, right? And then sometimes you need to do additional treatment of seawater, make sure minimize maybe water purification and minimize certain kind of pollution, right? So this is something, yeah, okay. Okay, so I think we almost run out of time for this today's lecture. I don't know, do you have any question about thing? I think this is almost the end of this semester. I do hope you can. I do hope you can have this kind of thing. One student asked, do we have some lecture on Thursday? According to this kind of our UST calendar, I think today is almost the last lecture. Why? So that calendar, so that I do think if you look at our academic calendar, so that we almost today should be almost the end of our this kind of lectures. Of course, as I mentioned, invite this. I get in contact with the vice president of the Rocket, this AR glass company. I asked them to give this kind of online, this kind of additional get lecture, so that at this moment we haven't finalized that exact date. Okay, but I will try to make announcement. Right, again, that is additional. Yeah. Again, we have I don't know. Do you have any question? Today is the last lecture. Right. Okay. So again, do you have any question? So again, one student asks, will the content test in the midterm will be tested again? The answer is yes. But of course, I would say majority, right? 80% of this kind of question in the final exam will most likely the content cover for those content after meetings. And we still have to test you something we mentioned in this thing. I do hope it's important for all of you to critically understand about all the content we discuss in the whole semester. Okay. Again, we only have most likely similar to the midterm exam, right? 25 MC questions. So we'll not give you 3 hours to 25. That doesn't make sense. Very similar to the midterm exam, online exam, so that you doing that so that you don't need to work too much. Okay. Again, so I do hope that you can learn something interesting, but of course, I don't mind. I do encourage you give a try about VR in your smartphone. Your smartphone have Google this map AR, right? The YouTube AR function, and also I don't mind to provide some additional free session for you to try Google the Facebook VR headset, and my peer student are going to get the Rocket AR headset, so that if you want, I do think it's worthwhile for you to give a try. And I show you all the big technology company put huge money in VR AR, a metaverse. There must be a reason. There will be huge potential market in the near future. I do think it's something of you to understand this thing. Okay, I think probably that's it for today's lecture. So that if you have additional question or something, please feel free to ask question on our Canvas website. So that again, I encourage to apply for the summer intern job. Again, I do think this kind of monthly salary is reasonable. And of course, I do have my own Euro project. If you want to work on some project, for example, low-cost optical microscope and other thing, COVID-19 project, you can also try to think also this kind of MEMS micro mirror or something. Okay, so again, so I think that's it for today's lecture. So if you're interested, feel free to ask question on Canvas website or send additional thing. Okay, bye bye. Hope now you can have this